I'm going to talk about some of the trackers that people are building around the world, and then a couple of commercial trackers. The first up, we already talked about this earlier in the day, but this is the QRP Labs U4B. I wanted to comment to Hans that I've truly enjoyed relearning my basic skills. It's programmable and basic to do various functions. It defaults to Whisper, but you can actually write little basic programs to do all kinds of different modes, and put up that little balloon glyph that some of you may have seen in the waterfall. You see the little balloon icon just outside the Whisper band. You can do that with this, and a variety of different modes. So thank you, Hans, for producing this particular board, and I hope you get the parts to make some more. I wanted to also mention WFikub has been flying a number of flights around the world using a variant of the Y03 ICT tracker, and he's also been flying some using SA6 PSS trackers. And so he decided to design his own with larger parts, because as you get older and your eyesight doesn't get quite as good anymore, it's hard to solder parts that are 0402 in size. So he wanted to make sure that everything was at least 0603 sized resistors, capacitors, and things that you can get into a easily soldered. So he designed this board. Basically, it's a modification of the Y03 ICT and SA6 BSS tracker, and he has a breakaway board with a LED status LED on it that blinks once a second during when it's the GPS is a lock, and it breaks away after it's programmed. But he's got a 6-pin header to program it. Uses the Atmel 328P and the AT-GM 336H for the GPS. Although I believe it's pin compatible if you want to use a U-Blocks Max 7 or 8 in its stead, because the original tracker was using a Max 7. So I modified the Y03 ICT firmware. Now you can switch between the telemetry method that Y03 ICT uses, which is the same as the QRP Labs. And then I also put a link in the a switch in the code where you can select my version of the telemetry encoding with the same firmware. So you can choose that when you compile it on the Arduino IDE. You can choose whether to use the QRP Labs format or my format for the telemetry string, which are different but very similar in how they're done. They still use the 0, 1, or Q for the telemetry channel. We also, there was code to do JT9 in there, and so I modified it to do a 10-character grid square, because the Whisper encoding method that we use is only a 6-digit grid square, which is about a 3 by 5 mile box. So it's something that gives you a little tinier box, particularly if it doesn't achieve float and you have to try and track it down. So I came up with a 10-character grid square, And there's very few places that tell you how to do a 10-character grid square. There's a lot of people that do 8, but I just went one more step in the same method that they use, and it's accurate within 100 feet or less. And so we had a flight that Tom did, and W5KUB-106, and it came down, it didn't achieve float, and he launched it from Memphis, Tennessee, and it landed somewhere in North Georgia. Well, I tuned into a remote SDR radio in New England, and I could hear the JT9 signal once it was on the ground. I could also hear the whisper signal that it was on the ground. But the JT9 gave me the 10-digit grid square, and it told me that this balloon had landed near this school. And in particular, that section of the school where the red star is, which indicated it'd be on the roof of the school. So several people picked up the 20-meter JT9 signal from 1,000 miles away or so. And so it confirmed the fact that it was showing this position. So Tom called the school, and the maintenance crew went up on the roof, and sure enough, his tracker was sitting right where that red star is, with part of the antenna in the trees. So that's one way of getting very fine and accurate position reports using HF modes. The only problem with JT9 is there's not a distributed network of ground stations that will automatically post this to a database that you can use. So it's strictly, the JT9 is strictly for people who can tune it in and listen for it directly, and but it won't you can't make an automated process out of it. Now, to post the position reports, I wrote a Python script that grabs the data from whispernet.org, codes the main call sign telemetry string, and then I reformat it into APRS format and send it directly to the APRS IS server. And so it shows up on the APRS.FI server as an APRS balloon would, and also is then picked up by SONDHAB or HabHub if it's above 2 kilometers. So although it's really fascinating to hear that you can set that up on the SONDHAB amateur site to actually show up below 2 kilometers. That's good to know, and thanks, Mark, for letting me know about that. I'll definitely be using that feature in the future. So the secret to these lower cost balloons, there's some silver mylar balloons by Orbs, ORBZ. Sometimes I've seen them listed as ORBS. And there's a couple places you can buy them from. They're called 32-inch spherical balloons. But you have to be careful where you buy them from, because sometimes the 32-inch balloons are really 18-inch balloons. They just measure the length from the top to the bottom. So truth in advertising is a real issue with some of these sites where you can buy them from. But if you want to buy an Orbs balloon, I don't have the link right with me, but it's Balloons-Online, I believe, sells it. And it's been pretty reliable for that. Now, the Yokohama balloons, which is the one you see here, is a clear balloon. It's not, doesn't have the metallized coating, and so it's lighter in weight and will go higher. And we get those directly from the Yokohama Balloon Company in Japan. The drawback is there's a $100 shipping charge. The good news is you will get your balloons within 2 or 3 days from Japan on your doorstep. So the longest I've heard it, taking was 5 days. So they send it through DHL. That's why it's $100. But if you buy enough of these, it kind of makes it cost effective because these are $17 a piece. If you buy a quantity of about 20 of them, and then you tack into the $100 shipping charge, it's still a lot cheaper than flying one of the SBS-13 balloons. And these will actually perform as well. In fact, I think they'll go a little higher. From the 2-3 test flights I've done, they've actually been similar in performance. And they're a lot smaller, and they take less lifting gas. The only drawback is you see that little tab on the left there. That's the filling port, and there's no other attachment port. So what I do is I take a really small hole punch I get from an arts and crafts store, and I punch a tiny little hole about a quarter the size of what a normal hole punch would be. And I use a hook weight on a scale to measure the lift with that hole. And then put Kapton tape on it, punch the hole through all of that, tie the string to it, and wrap it again with Kapton tape. A number of people also put some glue in the valve there to keep it from leaking. But I've had them stay up over 2 weeks or more without having put glue in them. We typically go up to about 0.3 to 0.4 psi overpressure to test them. And Tom made a homemade manometer with liquid and some dye that works pretty well. But you can also buy a manometer on Amazon that works well. In fact, Tom showed one on his slides that was a very nice manometer that gives you a digital reading of the actual pressure. So this is the upper left is the shows Tom's payload attached to the solar panels on a little piece of foam. He's been up over 30 days, and he went up over 50,000 feet. So I think his payload was 6.7 grams total with the antenna wires, solar panels, and everything. So, however, once it hit Japan, and it was a long ride to get there, but it's been a long, slow ride around the world at 50,000 feet compared to being at 40,000 to 42,000 feet. It makes a big difference in your average speed. And we're also in the summertime conditions. So actually, after he hit Japan, he's now taking a turn back in a retrograde orbit and heading back towards India. So another recent flight just headed towards India, actually, a couple of days ago. So I think it was AB5SS-91 or one of the flights.
Yeah, it was mine.
Yeah. Which one was that, John, that just went over India?
AB5SS-91. It was actually it went over Asia, hit Hong Kong, turned around, came back over Cambodia, India, Africa, and it's back out in the Atlantic now, trying again.
So Tom's flight is following in your footsteps.
Yeah, I guess so. Guess we caught the same stream.
So that's the fun in flying at 50,000 feet and during the summertime conditions. So, alrighty, and it took you 38 days to go around the world just recently with AB5SS-91. Alrighty, next slide.
Life at 52,000 feet is interesting, Bill.
Yeah. All right, next slide. And John, if you wish to talk this, go ahead and describe your tracker in the next few slides here.
Okay, thanks, Bill. This is the latest version of it. There's a couple previous versions, but this one is it's about 1.2 grams. It uses a U-block, so you can probably see everything on all the chips on there, but pretty basic tracker, U-blocks, GPS, Atmel processor. This one has one of the Chinese MS5351 chips on it. It does have an output filtering. It's a elliptical filter. And the main thing on this one was I used to have some FETs that I use for switching and turning on the GPS and oscillator, and I took those off to save parts and lighten it up, and it didn't seem to need the solar cells were able to power it without any problems, so I just took them off. The picture on the right is it's the solder paste laid down on top of the board. I use reflow solder. I do all this with reflow solder, and so I lay the solder paste down, put the chips on, and bake it for a little bit, and it comes out like the picture on the left. It's designed really to operate. So when I was building this board, I had to change software. So I found the Orion software, and so a lot of the schematic and pin choices are made to use Orion. Although I had to make several modifications to Orion, had to make it work above 12,000 kilometers, and also I modified it to use Bill's telemetry format. With one small exception, I don't need the solar voltage, so I'm using it to send temperature on the fourth character. But that's the board, and these are some other builds of the board. Using the board on a build. The antennas are 39 gauge magnet wire on top of 4 pound test fishing line. Although lately I've been using what is it, Litz wire, this small Litz wire for the down element. It seems to work fine, and I don't have to worry that much about soldering it and securing it to the bottom of the payload. I've been experimenting with some of the smaller solar cells. These are the ones on the right are, I think, 10 by, so those are your usual 19 by 52 millimeters. The ones on the previous slide were 10 by 52, and 7 of the 10 by 52s seem to power the tracker just fine. I think the most important part was getting the voltage up high enough for the LDO regulator, but they provided enough current to run the tracker down to about 18 degrees solar angle. Let's see, you keep going. The picture on the right, I built a little carrier, and it helps when you transport it up to the launch site. The current one, so the current tracker, AB5SS9 one's been floating about 52,000 feet pretty much consistently. And as Bill showed, oh yeah, the picture on the left is where we launched it. We launched it, it was a maritime launch on Lake Livingston, just north of Houston. Got on a boat, my friend's boat. He matched the wind speed and pretty much just let it go straight up. It was a great way to launch a balloon. One of the picture on the right is how we'd like to launch our balloons, of course.
Now, John, Meg mentioned what band that your tracker is on.
Oh yes, so this tracker is on 15 meters. I wanted to try and see how 15-meter propagation was, and it's worked out really well. I'm very happy that I chose 15. There's not as much, not as many signals as on 20 meters, and I haven't had a problem at all, being picked up, even in, even over Asia. It get picked up pretty well. I think I might want to try 10 meters next, but 15 meters has been very good. And of course, the antenna is shorter, so it's a little bit lighter. The tracker I built for 91 was 6.7 I think around 6.7 grams total. And it is on one of the Orbs balloons, the Mylar Orbs balloons. And Walter Holmes, who's on right now, he pre-stretched the balloon for me. And I believe he stretched that one to 0.5 PSI, which I was surprised because I haven't been able to get any of mine up to 0.5 PSI, but he got it up to 0.5 PSI, and we took it up to his house to fill it and seal the balloon. And then I took it up to Lake Livingston to launch it.
Excellent. Well, we look forward to having it continue its trek around the world if it decides to go east again.
Yeah, I don't know if I think I put the current ground track in one of those slides. I don't know if you have it or not.
I don't have it on here, so.
Well, as you can imagine, it took off and it went across Asia and hung out around Hawaii for almost 10 days, and then finally decided to make it across and make its first circumnavigation. Then took off again across Asia, but it hit Hong Kong and came back across Thailand and India and Africa. Now it's very, very slowly. I think it's about 1,000 miles off the Western Sahara coast. And last time I checked, it's moving like at 5 or 10 knots to the northwest. Yeah, to the northwest. And hopefully I'll catch a good, hopefully he'll catch a bit of a faster stream and come back across, and maybe I'll get 2 circumnavigations within 3 months.
Yeah, we actually launched W8BI-11 and it followed you quite a bit, and particularly right after I think you came through Japan about a day before W8BI did. That's the Dayton Amateur Radio Club's call sign, and so the Hamvention balloon headed off towards Hawaii and it hasn't been heard since. So we think it's either still circling around in the Pacific, went down to the Southern Hemisphere, or it came down. So, but we were following you for quite a while there. Well, thanks, John. I appreciate that. That's we look forward to tracking your flight further.
Yeah, thanks for including my trackers.
All right. And next slide, please. So the previous one, I wanted to show one slide before this. This is the super magnet, well, SD9 UOB's tracker. So Tom was mentioning that he had a magnet on his tracker during the winter to keep the solar panels pointing south. And if you look where the red arrow is on this screen there, where he's got the panels tilted down about 20 or 23 degrees, there's a super magnet stacked up on the edge there of one side of the board.
It's glued to the CPU. It's glued to the CPU.
It's glued to the CPU, okay. And that keeps it pointing so that the panels are pointing to the south, and the payload is lines to magnetic north. And you say that works pretty well, right, Tom?
Yes. It was working very well.
So a nice passive system. Since it's so lightweight, it becomes a compass.
Yeah, it was discovered about 2,000 years ago by Chinese.
Exactly.
Yeah.
Sometimes the old ways are the best. All right, next slide, please. This is the Now, we were talking about commercially available trackers. This is the one I came up with. We've got the U4B available from QRP Labs, Zach Tech from Harry. He's got a whisper tracker, and it's a whisper tracker, and it can do multi-bands. And then I offer the Sky Tracker. So I basically, mine's around 12 grams with the solar panels and the super cap attached, and the guitar string for the antenna wires for the APRS. And I use magnet wire for the whisper version. My goal is to make it completely ready to fly, just like the RTF model airplanes. So this is a ready to fly. You take it out, it's already programmed, it's already assembled, has the antennas and the string. And this has been great for school projects and people that want something that they can just pull out of the box, hook it up to an antenna, to a balloon, and let it fly. You have to measure the lift, of course, accurately. So that's pretty much for the market I have for this. And plus I'm using flexible solar panels because the monocrystalline cells are more efficient. If you don't have a good backing to them or protection, you can look at them sideways and they'll break in half. They're very fragile. Whereas these flexible panels, I get these from Power Film Solar, and they are practically indestructible. I've smashed them into the ground during launch in 20-knot winds, and students love to handle them and touch the cells. So I really like this when I'm doing a flight out of a school, particularly the younger students love to touch it. So. And I use a number 13 gauge Ernie ball guitar string. If you scrape it up with an X-Acto knife, it'll solder nicely to the board. And so it makes for a very lightweight payload. The brass tubing that supports the solar panels is made by Albion Metals. And it's a very lightweight 1.4 millimeter tubing. And it has the side benefit is that it's the actual ground return for the solar panels. So I only need a wire for the VCC to come out of the solar panels. So they provide support and act as a wire. So next slide. And if you want any information, just contact me with my call sign at gmail.com. I want to talk for those of you just getting into latex ballooning, the standard up and down flights. This has been an invaluable tool, the spot trace. Sometimes it's on sale for $49. You do have to buy a service plan that's a yearly fee, somewhere between $100 to $150, but it sends the position down to your website, and you can get the landing spot. And actually, during several recent flights, I've actually got full flight data on it. So it didn't used to, but usually it stopped around 20 or 30,000 feet. But some of the recent flights I've done have actually gone on up to altitude. So it's an invaluable 6-ounce insurance policy. And it gives you 2.5-minute updates. I do recommend, it's motion activated. I recommend you shake the payload right before you launch it though, just to get it activated. Next slide. This is a new tracker that I've been flying, not the Oreo cookie on the right, but the pet collar on the left. It's a JIO bit, and it's a GPS pet tracking collar. They have one for kids too. And it's really cool. There's a little app that you put on your smartphone, and you can see where it's landed and see the track. We've used it successfully in several recent flights at the University of Alabama, Huntsville. And it weighs about 5 to 10 grams. It's very lightweight. And actually, I think it's about 17 grams, I'm sorry. But you just charge it up before a flight. It's got, and it worked pretty well. We've used it to actually, it's a good backup tracker. It seems to work pretty well from the ground if it's in range of cell towers. And so far, wherever we've landed with it, it's worked pretty well. So there is a fee, monthly fee, but and I think the tracker itself is probably around $50. So, but it's a very lightweight solution for a backup tracker, particularly when it's on the ground. Next slide, please. Some people asked, what do I use, particularly if I'm in a car on HF? And I use the Funcube dongle. And the nice thing about the Pro Plus version, it does VHF, UHF, but it also does HF. And it's got some nice filtering in the front end. So some of the cheaper dongles that have HF, they have a lot of noise with them and a lot of broadcast interference. So these work beautifully. I actually use this for my home receiver when I'm not out chasing balloons, and I don't bother to turn on my big rig. I just use this as the receiver, and it works phenomenally well. Next slide, please. And I use HD SDR. It's a free program that works with the Funcube dongle and RTL SDR dongles. SDR Sharp, and I think there's SDR++. There's several different free programs that you can use, and you've got a complete receive station with just a little dongle you plug into the side of your computer. Next slide, please. I use MixW for APRS. It's been a great little program. It does cost money, but I find it puts a timestamp on there. If you make that option, it does a variety of other modes, but I've really been pleased with its performance, and this is my go-to for APRS. MixW.net is where you can download it. You can also use the free Direwolf program, which also functions as an IGATE, but it's a little clunkier to set up. You have to set up a text file interface. The trickiest part is getting your audio inputs set up correctly so it works. That's the most frustrating part of all this. Next slide, please. So to get if you're operating as an IGATE, I use APRS IS32, and it works with MixW or SkySonde. We use SkySonde to decode the ozone sondes that we chase here. And you can set it up for either one, and this IGATE software will send out whatever you receive, whatever mode. I mean, I picked up Tom's SB9 UOB's Contestia signals as he flies over my house. I picked up his trackers many times as they fly over Alabama, and different modes, and I can gate it into different tracking. The nice thing, I also use DLFL Digi, And FLDigi was written by a fellow who lives just 20 miles north of me here in northern Alabama. The DL version is a modified version of it, of FLDigi, that allows it to track various balloon modes and send it to the HabHub servers, habitat servers. All right, next slide, please. So I wanted to show you some of the things that W5KUB has done with a huge zero pressure balloon. He was trying to make a super pressure balloon out of it and was covering it with a mesh to make a super pressure balloon out of it. He calls this the mother of all balloons. And the first test flight he did of this, and actually the only flight he's done, ended up in a tree on the coastline of South Carolina. But it did not achieve a float. It developed a leak, but it was a monster balloon. Next slide, please. A lot of people have asked, since we're doing pico balloons a lot, you really don't need a huge 200 to 300 cubic foot tank of lifting gas. I go to my local mom and pop welding store, and they have a relationship with Airgas and different gas suppliers. And I get a little 40 cubic foot tank of helium, and I have a little 40-foot tank of hydrogen. The aluminum version of this tank only weighs about 15 pounds, so it's very easy to carry and transport. And they charge me $38 for 40 cubic foot of helium, although right now it's doubled in price. And they have a moratorium on helium such that if you aren't an existing customer, they won't even sell you helium. So hydrogen, though, will cost you pretty reasonable. And it's in the same cost range as those balloon time helium tanks that you get from Walmart or Dollar General. But you only get 80% helium from balloon time helium. And actually recently, I think it's even less than that from what I've seen in flight performance when people use that. They're convenient. They're not cheap anymore. They're raising in price. This little tank I got from my welding supply store was actually the same price as what you can get a balloon time helium tank from Walmart or Dollar General. That's pure helium or pure hydrogen. Of course, hydrogen will work better and you'll stay aloft longer and you go higher. And next slide, please. With that, I'll stand by for any questions. This is actually a flight we did for the Weather Channel. It took $7,000 worth of helium and 47 tanks of helium and 66 weather balloons. And that's the chair from the movie Up. We had a chair, well, it's an animated film, so there wasn't an actual chair that the old man would sit in, but we modeled it from their drawings. So that's a replica of the movie Up's easy chair. And we sent this guy up to 14,000 feet for 9 hours, and he went 150 miles downrange. So any questions? With that, back to you, Mike. Does just a question, does anybody else working on a tracker design that they'd like to mention?
At some point, I'll be redoing my WISP tracker just because all the parts for it are on titanium now. So at some point, I'll go through a respin and I'll probably, make it smaller, better, faster, stronger. But nothing immediate.
And Roger Hammond, do you have any comments on what you're working on?
Oh, nothing fancy, Bill. It's some of the other people's work. Ours is actually going to be a little piggyback or daughter board on a Spark Fun SAMD breakout board. Weight wise,
We lost you, Roger. I think you bumped your mute.
there I was holding on the space bar. Apparently it timed out. Anyway, we have the boards ordered. They should be here in about a week or so. We'll get one populated, do some testing, and maybe by the end of summer we can have something aloft. We'll see how it goes. We're definitely the newbies.
I can just show you what I'm going to be flying tomorrow if the wind behaves. Get it in frame here. So that is, yes, a U-Blox GPS as everybody flies, and one of those DR118 VHF radios, an Arduino, charge controller, LiPo cell, and solar cells.
You can get enough hydrogen in that bubble wrap to float it.
We can try.